Hello, I Kiran Mudredi, Assistant Professor, Department of Computer Science and Engineering, Bellary Institute of Technology and Management, Bellary. Welcome you to yet another class of system modeling and simulation. In this video lecture, we are going to begin with a continued version of queuing models, that is part 2. In this video lecture, we are going to see the contents, the performance of a queuing system, how to measure the performance of our queuing systems, and two different types of Markovian models, steady state behavior of infinite population models, that is M slash G slash 1 queues and M slash M slash 1 queues. Okay. Let us move ahead with first topic, long run measures of performance of a queuing systems. There are totally five important parameters to analyze the performance or to measure the performance of any queuing system. The first one is called L. L stands for long run time average number of customers in the system. How many number of customers are there in a system is called L, and how many number of customers are standing in a queue is called LQ. W stands for the average time spent in a system per customer, and similarly LQ stands for the time spent in a queue per customer in a queue, and rho is called server utilization. Okay, these are the five important measures of a performance of a queuing system. Let us understand the formulas. What the formulas which are used to calculate L, LQ, W, and WQ. Let us move ahead with time average number in system, that is L. Consider a queuing system over a time period T. That means it begins with time 0 and ends with some time T, in which a system contained exactly I customers. Okay, and these things you will come to understand while solving examples. Okay, so the only thing is we need to remember these formulas. It is L is equals to 1 divided by T summation I is equal to 0 to infinity I into Ti. Okay. Similarly, LQ is time weighted average number in a queue, that is 1 divided by T summation of I is equals to 0 to infinity I into TQ. These are the measure the performance of a queuing system L and LQ. Let us understand one example. We are going to calculate time average in a system, that is stands for L, is equals to, that is according to the formula, summation of I starts with 0 to infinity. Okay, that's what L is equals to summation of how many T's are there here times T1 is there, T2 is there, T3 is there. Okay, there are totally three times are there. T1 0 into, it begins with 0 time, I is equals to 0 into T1. T1 stands for T1, T1. So initially T naught that begins with 3, that is what 0 to 2, and it is up to 3. T naught, it begins with T naught, sorry, 0 to 3, that is 0 into 3 plus I value begins with 1, T1. This is T naught, this is T1. T1 is 12. How exactly it is 12? I will tell you. T1, it begins with 0, that is 1, 2, 2, 3 and 4, and again here 4, 10 to 14, that is 4, and 16 to 20. 4 for 4 plus 4 plus 4, that is 12, plus T2, 2 into T2, that is these two, T2 and these two. Totally it is 4 plus 3 into T3. T3 is how much? Only 1. So it is 0 into 3 plus 1 into 12 plus 2 into 4 plus 3 into 1 divided by total time, that is T, that is 1 divided by T, the formula, according to the formula, that is 1 divided by T. So that is 23 divided by 20, 1.5 customers. This is a L value calculation. Similarly, LQ we are going to calculate with the help of the same formula, 1 divided by T, 0 into T naught, that is 15. How it is 15? Here it is 5, again 10 to 20, that is 5 plus 10, that is 15. T1, T1 is this one, this is 2, this is 2, that is 4, and this is T3, that is 1. So if you calculate, you will get 0.3 customers are weighted in a queue. Similarly, W we are going to calculate. W stands for weighted time, the average time spent in a system per customer, that is W, and per customer how much he waited in a queue, that is 1 divided by n, summation of I is equals to 1 to n W of I, and WQ is equals to 1 divided by n, summation of I equals to 1 to n and W of I raised to q. So here understand, this is a given problem statement, and the graph is given. W is equals to W1 plus W2 up to W5 divided by 5, total number of customers. So it is very easy to calculate W1, that is 2. W1 is nothing but 0 to 2. Arrival is begins with the 0 and departure is at 2. So it is 2 plus W of I is calculated. DI stands for departure, AI stands for arrival. So departure of A2 is at 8. Look into this. Departure is 8 minus arrival is at 3. That is 8 minus 3 plus third customer. When next customer departure departure is at 10. Arrival is at 5. A3. When I'm talking about A3, it arrives at 5 and departure is 10. That is 10 minus 5. Similarly, it goes on, and this is a numerical calculation. Just divide it, you will get 4.6 times unit. Similarly, WQ is going to be calculated with the formula. So, if the weighted, how much time does he waited? No waiting, W1, so it is 0. W2 also not weighted. This is 3 because he waited in a queue, that is uh, 10 minus 7. Okay. Similarly, the next customer is also weighted, so it is 0. So it is 1.2 time units. Okay. In this way, we need to calculate. Uh, so now let us move ahead with types of Markovian models. So this is a Kendall notation, m slash g slash 1 slash. These are infinite population models. So in this way, we are going to represent m slash g slash 1 server, infinite queue length, infinite population model. This is arrival, this is departure. This single server queue with Poisson arrivals, and this is standard variance, and this is rho, that is lambda divided by mu is less than 1. So these are derivation is not required. We need to remember these formulas. Okay, rho, p naught, l, w, lq and wq. So that is server utilization, probability of empty system, a time average customer in the system. Okay, This is time spent per the customer, LQ, okay, in a queue, and this is time average spent in the system. So these are the formulas we need to remember if we need to solve a problem on m slash g slash 1 slash infinity queues. Understand? Let us go ahead with example. Two workers, Abel and Baker. It is revisited again. So lambda is given, that is 2, 1 divided by 30 per minute. Okay, and Abel 1 divided by mu is 24 minutes, and mu square is given, standard variation is given 20 square, that's 400 minutes. LQ is equals to, the formula is used, LQ, the same formula is substituted here, 1 divided by 30, that is 1 divided by 30, this formula is used, LQ, okay, 1 divided by 30 plus 24 plus 400 divided by 2, 1 minus row, 2 into 1 minus row, that is 4 divided by 5 is given in the problem statement. So this is 2.71 customer, okay, that is 20 divided by 24, that is nothing but 4 divided by 5. Okay, similarly it is calculated in this way, WQ, and m slash 1 Qs. Okay, these are also the formulas we need to remember while solving the problems. Similarly, how exactly we done with g slash 1. So these are measure the performance of a system. Let us understand the given unisex hair styling shop. Here lambda is equals to 2 customer per hour and mu is given, that is 3 customers per hour. This lambda 2 stands for 2 customer will go out of the saloon, and 3 customers are arriving to the system. So rho is equals to lambda divided by mu 2 divided by 3. V naught is equals to 1 minus rho, that is 1 minus 2 divided by 3 is equals to 1 divided by 3. Similarly, we are calculating P1, P2 and so on. That is P1 is equals to P naught into rho to the rho raised to 1, that is 2 divided by 9. This formula we are applying. Okay, the same formulas are substituted to calculate steady state parameters of this one. Okay, lambda is 2, mu is 2, 3 minus 2, that is 2 customers. Similarly, we are applying all the formulas to get the answers. Try to solve it by using calculator and try to find out the answer and compare it with the problem. Similarly, another example, a lambda value is given and mu value is 10. Lambda values 5, 6, 7.2 and 8.64. So these values are taken. Okay, it is given in the problem statement. We are calculating rho, that is 0.5, 0.60, 0.72, 0.64. Okay, and here L is going to be calculated with the formula. L is what? We are applying lambda mu minus lambda. If you apply, you will get L, and W is calculated with the help of this formula, L divided by lambda. Okay, the same thing we are putting in a graph. Number of customers. This red color stands for long time average time spent in the system. Here W stands for long time average time spent in the queue. Okay, if you try to find out these values and put it in a graph. This is the problem associated with m slash 1.